Okay, so today we want to look at differentiating powers of x using a more streamlined approach than perhaps differentiating by first principles or using the limit definition. So the basic idea here is that the derivative of some power of x is just given by taking the power to the front and then just subtracting 1 from the power. So let's see how that applies in a few examples. So let's look at f of x equals x cubed. In this case, n is equal to 3. And by this rule here, what we see is we bring the 3 down. So I'll write f prime of x for the derivative is 3x to the 3 minus 1. And we end up with 3x squared. Okay, let's look at a slightly more complicated example. Here we have f of x is equal to x to the 5 plus 3x plus 8. So here we can just differentiate each term individually and then add them together. So we'll have 5x to the 5 minus 1 plus, this is 3x to the 1, and this 8x can be this 8 can be 8x to the 0, and so what we'll find is that we'll get a 3x to the 0, and then this just becomes 0 because we'll end up multiplying by 0. So if we simplify this, what I end up with is 5x to the 4 plus 3. Okay, let's look at slightly more complicated example again. Here we have x to the 1/2, so I can write f of x as x to the 1/2, and then by the rule again we see that f prime of x is 1/2 x to the 1/2 minus 1. 1/2 minus 1 is minus 1/2, and if we want, we can leave it like this, but we can also just simply write the derivative as 1 over 2 square root of x by index laws. Okay, so one last example. Let's look at f of x equals x to the 3/2 plus 1 over x. What we'll do is we'll start by writing f of x as x to the 3/2 plus x to the negative 1, and then just applying the rule, we end up with 3 on 2 times x to the 3 on 2 minus 1, plus the negative 1 comes down, and I get negative 1 minus 1. So I'll end up with 3 on 2 x to the 1/2 minus x to the minus 2. And by index laws, I can write this as 3 square root of x divided by 2 minus 1 over x squared. And that's it for this video. If you liked it, please hit the like button, and if you want to see more of this content, I'd appreciate it if you subscribe to the channel. Thanks guys, I'll see you in the next one.